I'm going to briefly describe the spreadsheet we've created that contains complete steam tables. I've indicated here the website location, and so it contains 3 worksheets. One that shows the saturated properties of water versus pressure, and one shows the saturated properties versus temperature. And then the third one contains properties of superheated steam, compressed liquid, and supercritical fluid all in one worksheet. And at the top of each of these worksheets there's an interpolation table. And so what these tables do is allow you to determine properties without having to do interpolation yourself. It does the interpolation automatically for you. And so what I want to do is show you the spreadsheet and explain these interpolation tables. So the first thing you'll notice is you have to enable content before you can use the spreadsheet. And this first page has an explanation of what's in the spreadsheet and how interpolation is done. And so let's look at the table for saturated liquid and vapor as a function of pressure. And so the table is extensive, so fairly fine-grained, and you'll notice that what we've done is freeze the top part so you can see the values without having to check what the columns represent. And the idea here is if you enter a pressure, for example 4.63, it's going to do the interpolation between 4.6 and 4.7, find the temperature, and then find the properties for you so you don't have to do interpolation. So this is a function of pressure, and you'll notice the idea is the same. So if I were to enter 115.3 here, it's going to do the interpolation and find the values. Now if we go to the last worksheet, when it's done enter, you notice the pressure 0.125 and the temperature 135.4. Now you'll notice there are 4 rows where it's looked up values, because that's doing double interpolation in this table. Right? This table has liquid values, shows saturated here, but then it has superheated vapor, again saturated. And if we scan down, it's a very extensive fine-grained table, but if I go far enough, high enough pressures, then what I'm going to see is supercritical fluid, right, as we get above the supercritical conditions, and then we get also compressed liquids at high pressures. But the nice thing is you don't have to scroll down to all those values. You can enter the conditions of pressure and temperature that you're interested in, and automatically gives you the value and tells you what phase it is.